Hello everyone, you're welcome to this channel once again. Today we have another question bordering the jet propelled aircraft and how to calculate the maximum payload delivered from one point to another. Once again, how to calculate the maximum payload delivered from one point to another using a jet propelled aircraft. Now let's read through the following question. Consider a jet-propelled airplane with the following parameters: the wing area X, 50 meters squared, the wingspan B, 25 meter, the zero lift drag coefficient CDO, 0.02, the Oswald efficiency factor E, 0.8, the thrust specific consumption TFSC, 0.65 kilonewton per kilonewton hour, the operational mass, that is the mass of the empty aircraft and the pilot, MOP equals 8,500 kilogram, the maximum takeoff weight of the aircraft, which is 13,000 kilogram. Now, the aircraft has to deliver the payload by airdrop from airport location A to B. The distance between the location A to B is 2,000 kilometers. The mission consists of three phases. First, climb from airport location A to 10,000 meter altitude, where the air density equals 0.41 kilogram per meter cube. 2. The cruise to location B. 3. Cruise flight at the same altitude back to location A. The payload is dropped by parachute at location B from the altitude 10,000 meter. Ignore the descent phase at the end of the mission. The fuel consumed during the climb phase is MFC, which is 500 kilogram, and the distance covered during the climb phase is 100 kilometer. Calculate the maximum payload that can be delivered by the airdrop to location B. Now, today we have a jet propelled aircraft with the parameters of the S wing area 50 meters squared, the span B 25 meter, CDO 0.02, the Oswald factor 0.8, the TSFC 0.65 kilonewton per kilonewton hour, the MOP, the mass, that is the mass of the aircraft with the pilot, 1,500 kilogram, the maximum takeoff weight, 13,000 kilogram. The distance from A to B, that is the distance from airport A to B, equals 2,000 kilometer. That is 2 to 10.6 meter. the altitude of the flight, 10,000 meters. The density at the altitude, 0.41 kilogram per meter cube. The mass of fuel consumed during the climb, 500 kilogram. The distance covered during the climb, 100 kilometer, which is 10 to 5 meter. Now we have to calculate the payload, the mass of the payload delivered. By using Breguet Range Equation. R equals 1 over TSFC to the root of HG over rho S to CL CD max, the root, multiplied by the root of initial mass minus final mass. Which is a Breguet equation. So therefore, the first of all, we need to calculate the CL, that is the coefficient of lift. The coefficient of lift, by using the formula, is pi over 3 EARCDO. Our CL becomes pi over 3 times 0.8 times 12.5, which is the aspect ratio. AR becomes P square over S, that's 25 square over 50. This is 12.5. Multiply by 0.02 all into root. So our CL becomes 0.46. Don't let us forget we need to calculate our CD. CD equals 4 over 3 CDO. That becomes 4 over 3 times 0.02, which gives us 0.027. So our CD equals 0.027. And don't let us forget that to calculate the K constant, which is 1 over TSFC, the root of 2G over rho S to the root of CL over CD max. So this is our constant for the Breguet equation. So our constant becomes 3,600 over 0.65 the square root of 2 times 10 times the density, 0.41 times 50 multiplied by the CL, the root of 0.46 over CD, which is 0.027. Our K equals 2.78 times 10 raised to the power 5. Don't let us forget that the range from airport A to B equals 2 times 10 raised to the power 6 meter, and the range for the climb equals 10 to 5 meter. Now, in order for us to find the payload or the mass at B, the equation becomes RA to B equals the range, that is the distance covered during the climb, plus the K constant of the Breguet equation multiplied by mm, maximum takeoff weight, minus the mass of the fuel during the climb, minus the mass at airport B. So if we put MB out, our MB, that is the mass at airport B, becomes the maximum takeoff weight minus the fuel of the climb, minus the range A to B, minus the range of climb over constant, all square. So our MB equals the root of 13,000 minus 500 minus 2 times 10 raised to the power 6 minus 10 to 5 over 2.78 10 to 5 squared. So our MB equals 11,020 kilogram calculated. Now, to find the range B to A, that is distance covered while the aircraft is returning back to the initial airport, which is A, our equation becomes the K constant of the Breguet equation multiplied by the root of MB minus the payload. You remember, the payload has been dropped while returning back. So we subtract it from the MB. So the payload is subtracted from the MB minus the mass of the operational. So our RB to A equals K So from here we can pull out the mass of the payload. So the mass of the payload equals mb minus rb to a over k plus the root of mop square. The mass of the payload equals our calculated mb minus 2 to 6 over 2.78 to 5 plus root 8,500 squared. It gives us 1,001 for 0.70 kilogram. So the mass of the payload equals 1,140.7 kilogram calculated. Thank you for staying tuned.